Humanoid robots, once a distant science fiction concept, are quietly becoming one of the most consequential technologies of the 21st century. They promise a future where machines are not limited to fixed arms or rigid industrial stations, but instead can move through human environments, manipulate everyday objects, and perform complex tasks with a mix of precision and autonomy. Behind this transformation is a global competition involving three major power blocks: the United States, China, and Europe. Each region brings its own strategy, strengths, and ambitions. Each faces different challenges, and each is racing toward a future where humanoids could reshape manufacturing, logistics, construction, healthcare, defense, and perhaps one day, daily life. This is a deep, structured, and truthful look at the global race for humanoids, exploring how these three regions are building the next generation of intelligent machines. Introduction: the arrival of general-purpose robots. In factories around the world, robotic arms have been performing repetitive tasks for decades. But these machines require highly controlled environments. They cannot walk across uneven floors, navigate cluttered rooms, or adjust to sudden changes. Industries struggling with labour shortages, rising costs, or declining productivity are searching for solutions that allow machines to work with humans, not apart from them. Enter humanoid robots, machines designed with legs, arms, sensors, and AI systems modelled after human capabilities. They do not just automate, they adapt, navigate, perceive, and learn. The ambition is sweeping: robots that can operate in any environment built for humans. Governments and corporations know what's at stake. The nation that achieves dominance in humanoid robotics will gain economic leverage, supply chain resilience, military advantages, and enormous soft power. This race is not only technological, it's strategic. Nowhere is this more visible than in the competition between the United States, China, and Europe. The United States, winning the software war. The United States approaches robotics the same way it approached the internet, smartphones, and artificial intelligence, by building the most advanced brains rather than the largest factories. Its strengths come from a unique ecosystem: Silicon Valley's software talent, world-leading AI labs, and hardware innovators clustered around tech hubs. American firms dominate the field of large-scale machine learning training, robotics simulation, vision language action models, and the AI chips that power them. Humanoid robots developed in the US increasingly exhibit fluid movement, high-level reasoning, and the ability to perform complex tasks in ever-changing environments. Companies like Boston Dynamics pioneered robust locomotion. Tesla, with its Optimus project, pushes toward a future where robots benefit from shared neural networks and enormous self-driving datasets. Meanwhile, companies like Figure, Agility, and NVIDIA contribute breakthroughs in manipulation, control systems, and robot learning frameworks. The United States excels in the upper layer of humanoid intelligence. Adaptable AI models that can generalize across tasks, advanced simulation environments that accelerate training, cloud-based architectures that distribute robot intelligence globally. In essence, the US builds the operating systems of the robotic future, but America's strengths are matched by clear challenges. Scaling hardware manufacturing remains slower and more expensive compared to Asia. Export controls on critical chips restrict the broader supply chain, limiting collaboration abroad. And mass market production, essential for widespread adoption, runs into high costs and limited capacity. The US leads in the software dimension, but the humanoid revolution also requires hardware at scale. On that front, another global competitor is moving at extraordinary speed. China's approach to humanoid robotics is shaped by its industrial history. For decades, China built the world's manufacturing engines, powering global supply chains. Today, it leverages that same ecosystem to accelerate its humanoid robot ambitions. The strategy is aggressive, coordinated, and heavily supported by government incentives. China aims to build humanoids the way it builds electric vehicles, batteries, and consumer electronics, in massive quantities and at dramatically lower cost. Chinese institutions focus on building domestic supply chains for motors, actuators, sensors, and batteries, producing humanoids at scale, often far exceeding Western production volumes, rapid field deployment, using factories, logistics hubs, and research parks as real-world testing grounds. Analysts estimate that Chinese manufacturers could produce more than 10,000 humanoid units in a year, over half of global output. This scale advantage drives costs down and accelerates industrial adoption. For companies operating in manufacturing, logistics, or e-commerce, humanoids could help stabilise labour shortages and reduce long-term costs. China's strengths lie in volume and speed. Factories integrate new components quickly, iterate rapidly, and bring prototypes to market faster than most Western competitors. Yet challenges remain. While hardware production is booming, high-level autonomy and advanced robot brains still lag behind American capabilities. US restrictions on advanced processors hinder access to top-tier AI chips, and large-scale deployment in public or home environments raises questions about safety, reliability, and regulation. Even with these challenges, China's growth in humanoids is staggering. If the US leads in intelligence, China leads in bodies, the physical machines that will populate future workplaces. Europe does not rush toward humanoid robotics with the high-speed aggression of China or the high-tech dominance of the United States. Instead, Europe plays a quieter but critical role, building the components, standards and regulations that ensure humanoid robots can operate safely in the real world. For decades, Europe has been the global centre for precision engineering. Many of the most advanced robotic actuators, servo systems, encoders and industrial sensors originate from European firms. This engineering heritage makes Europe a natural supplier for high-quality humanoid components. The continent also leads in regulation. The EU AI Act and upcoming machinery regulation create clear frameworks for safety, accountability and deployment. These rules may slow rapid experimentation, but ensure robustness in critical sectors such as healthcare, transportation and industrial automation. European companies often adopt a conservative but reliable approach. Focus on safety-first deployment. Target industrial and niche applications where precision matters. Integrate humanoids into environments with high compliance requirements. Europe's advantage is trust. Industries that demand reliability, automotive manufacturers, aerospace suppliers, medical equipment providers already depend on European systems. These same sectors may look to Europe when adopting humanoids for regulated, high-stakes operations. However, Europe faces structural challenges. Its market is fragmented across languages, regulations, and economic policies. Large-scale manufacturing capacity is smaller compared to China. And its humanoid robotics ecosystem grows more slowly due to regulatory overhead and limited focus on mass-market robots. While Europe may not define the volume or intelligence frontier, it is likely to define the standards, components, and certification processes that enable humanoids to operate safely worldwide. When comparing the United States, China, and Europe, it becomes clear that each region pursues a fundamentally different goal. These are not three identical competitors fighting over the same finish line. They are pursuing overlapping but distinct achievements. The US model: build the smartest humanoids. Focus on AI, general purpose learning, advanced simulation, and high-end robotics systems. The Chinese model: build the most widespread humanoids. focus on cost reduction, supply chain dominance, manufacturing scale, and rapid deployment. The European model, build the safest and most reliable humanoids. Focus on regulation, precision components, industrial integration, and certification. These three strategies create a triangular balance. The United States sets the pace of intelligence. China sets the pace of industrial scaling. Europe sets the pace of safety and compliance. The region that succeeds long-term will be the one that integrates all three dimensions. Despite being competitors, the regions are interdependent. American humanoids often rely on Asian supply chains for motors, sensors, and batteries. Chinese humanoid development depends on American-designed AI chips and software architecture. European components and standards integrate into systems built across both the US and China. Yet this interdependence is fragile. Trade restrictions, especially on semiconductors, can slow technological exchange. Regulatory divergence may create barriers between markets. Political tensions could fracture supply chains that humanoid robotics rely on. In a globalized market, the humanoid robot race is both collaborative and competitive, with alliances shifting as technology advances. By 2030, analysts expect humanoid robots to transition from prototypes into mainstream industrial tools. The first major markets will likely be manufacturing, where robots can assist with repetitive or dangerous tasks. Logistics, with humanoids navigating dynamic warehouse environments. Construction, using mobility and manipulation to support skilled labour. Healthcare and elderly care, especially in ageing demographics. Retail and hospitality, filling roles where labour is scarce. The transition from niche machines to general-purpose assistance will be driven by declining costs, advances in autonomy, stronger AI models, improved reliability, and acceptance within regulated sectors. The global race for humanoids will determine not only economic power, but also how societies adapt to intelligent machines occupying human environments. In pure intelligence, the United States leads. In mass production, China leads. In safety and regulation, Europe leads. No region has full dominance, but all are accelerating. The long-term winner will be the region, company, or alliance capable of unifying the three pillars: smart, scalable, and safe humanoid robotics. The world is entering an era where intelligent machines will not just work alongside humans, they will reshape industries, redefine labour, and influence geopolitical balances. The race is underway. The stakes are enormous, and the outcome will shape the next century.